Ladies and gentlemen, I know it's been a while, but welcome back. This is the video lesson for section 4-6, that's chapter 4. Section 6, entitled Isosceles and Equilateral Triangles. This particular set of videos will be two videos. The first video will cover the background information for the lesson, the vocabulary, the theorems and postulates, and corollaries, which is a new vocab word today. And the second video will show examples of the types of problems that will be on your homework assignment. So we're starting off here looking at an isosceles triangle, ABC. We are going to put some vocabulary in place referring to isosceles triangles. Now, an isosceles triangle has two congruent sides. Those two congruent sides will be referred to in this course as the legs of the isosceles triangle. So AB and BC are the legs because they are the same length. Now, don't get this confused with the right triangle vocabulary we already have, where the two sides that were not the hypotenuse are called the legs. This is a whole different set of stuff. Okay? Now, when we're looking at this, the third side of the isosceles triangle, this would be the side that is not congruent to the other two sides, is known in this course as the base. So AC is the base of the isosceles triangle. Now, what we need to be able to do is recognize that base. That is key because we need to understand that the base is not the same length as the legs. Now, as for the angles, the angle at each end of the base, that would be angles A and C, will henceforth be known as the base angles of the isosceles triangle. And the third angle, the one up here between those two congruent sides, is going to be known as the apex angle in this course. Now, it's not that important that we remember the word apex angle. What is important is that we can visually identify the base angles and understand the properties of the base angles as they relate to the triangle overall. Now, this leads us into what is called the Isosceles Triangle Theorem. And this is worded as if we don't have the vocab that we just put in place. So I will explain it again in words after I fill in these blanks. If two sides of a triangle are congruent, in other words, if the triangle is isosceles, because it has two congruent sides, then the angles opposite those two congruent sides must also be congruent. In other words, in symbols, what we're looking at here is if we have an isosceles triangle where AC is congruent to BC, as seen over here in this picture. See the markings? That means, so then, that angle B must be congruent to angle A, because angle B is opposite side AC, and angle A is opposite side BC. So that is the Isosceles Triangle Theorem. Essentially what it is saying is, if a triangle is congruent, what am I talking about? Let's try that again. If a triangle is isosceles, is what I meant to say, then the base angles are congruent. That is another way to state this exact same rule. If a triangle is isosceles, then the base angles are congruent. Okay, the converse of that theorem is also true. That is that if there are two angles in a triangle that are congruent, then the side lengths, the sides opposite those angles, must be congruent as well. Okay, so in the picture, once again, it says if angle A is congruent to angle B, then what that tells us is that the side lengths opposite angle A and angle B must be congruent as well, which means that side BC must be congruent to side AC, because BC is opposite angle A and AC is opposite angle B. So again, another way for us to say that is if the base angles are congruent, this is why it's the converse, then a triangle is isosceles. So again, there's a couple different ways to say it, but what it boils down to is anytime we have side lengths that are congruent, that means the angles opposite those sides must be congruent as well, and vice versa. Now that leads us into our only new vocabulary word of this section, which is the word corollary. Hope I'm pronouncing that right since I'm going to be putting this on YouTube. A corollary, which is a vocabulary word which will be on your final exam, is a conditional statement, so if then, which follows logically from a previously proven theorem or potentially from a postulate, which would not require a proof, without an additional proof. So we just had a theorem a minute ago and we didn't prove it, probably should have, but that's okay. That theorem said that when two sides of a triangle are equal, the angles opposite those two sides must be congruent. Well, if that's true for two sides of a triangle, we should be able to extend that out to cover three sides without doing an additional proof. Because if two of the three sides are congruent, you could do any two of the three. And that would mean that the angles opposite any two of those three sides would have to be congruent. So these are the equilateral triangle corollaries, which state that if three sides of a triangle are congruent, then that means that the three angles of that triangle must also be congruent. That's the corollary from the Isosceles Triangle Theorem. And then there's also a corollary for the converse. If all three angles of a triangle are congruent, that is enough for us to state that all three sides of the triangle must be congruent. Now, when I taught you lesson 4-1 and we talked about classifying triangles by name, I said that. I didn't formalize it into a proof, but I said that. I said anytime that a triangle is equilateral, that means that triangle is also equiangular, which are fancy words for equal sides, equal angles. And that actually goes both directions. If we have an equiangular triangle, it must be equilateral. That will do it for the first video here. We'll have one additional video for this section showing the examples that will be on your homework.